I'm going to take a moment in honor just to make a formal introduction of Raymie as an advisor as we settle into the Nature Center here. Raymie's wonderful, and he goes to background a lot, and he's in outdoors, and he utilizes down in new school to follow his passions. And that's why Raymie's inspirational. And then to teach us and to express your passion here in an immersion experience makes me totally proud and excited. So thank you, Raymie. Let's give him a hand.
Before I start, just a little tip for everyone. Those birds out there, they're going to be way more entertaining than anything. What do you think is the biggest threat to the animals and plants that inhabit the Earth today? Most people respond to this question with an answer like climate change or pollution. And yes, those are huge issues to species around the world today. However, that's far from the biggest issue. The biggest threat, one that is threatening over 85% of animal, plant, and fungi species on Earth today, is the destruction of habitat for development, agriculture, and other uses. I'm sure you've heard of it, but it's not likely something you think about much. To most people, habitat loss is something that happens to orangutans in far-off jungles. In fact, that photo of sad orangutans was literally the first photo that came up when I Googled habitat destruction. That was like, I was thinking of that as an example. Like, oh, most people are going to think of orangutans, and then I Googled it, and it was actually orangutans. But it's not just an issue in Southeast Asia and Brazil and other tropical, far-off places. It's an issue right here in Wisconsin. Once upon a time, but really only a couple centuries ago, Wisconsin was a vast wilderness. Most people think of historical Wisconsin as like one big forest, but that wasn't really the case. While there was lots of forests in northern Wisconsin, southern Wisconsin was largely prairies, marshes, and savannas. Over time, most of this habitat was destroyed for one reason or another. Forests were logged, marshes were drained, prairies were plowed. Many animals suffered from this. Many species became extirpated in Wisconsin, meaning the loss of habitat hit them so hard that they could no longer survive in Wisconsin. Here's just a few of them. You can see that one right there. But I want to put particular emphasis on this one, the Carolina parakeet. Yes, believe it or not, Wisconsin has, or more rather, had, a native parrot species. The Carolina parakeet lives in deep woods in southern Wisconsin, especially along the edges of Lake Michigan, the southern Kettle Moraine region, and the bluffs of the Driftless area. Logging hit the Carolina parakeet hard, before it eventually became extirpated in the state in the early 1900s, and eventually extinct globally in 1939, when the last bird died at the Cincinnati Zoo. Today, there's still not that much habitat available in Wisconsin. Most of the remaining natural areas in the state are forests and northwoods, and even these do not resemble their original state after a couple centuries of logging. Very little natural habitat remains in the southern half of the state. Specific habitat types, such as prairies and savannas, are essentially completely gone from the state. Luckily, there is some hope for wildlife around the world that are threatened by habitat loss in the process of ecological restoration. But before I go there, let me talk about my history with this project. For those of you who don't know, which I imagine is relatively few, I'm a birder, which means I observe birds in their natural habitat as a hobby. Here, I took all those pictures, by the way. To date, I have seen 373 bird species in the wild. I love seeing birds that I've already seen. I'll never get tired of the most common ones. I especially like seeing birds that I haven't seen before. There aren't many Wisconsin bird species left that I haven't seen, but one in particular sticks out to me. This one. this because of how close it is. See, piping plovers only nest on sandy beaches on the Great Lakes, which there's already a limited number of. And they hate human disturbance. If there's too many people on their beaches, they can't nest there. So finding a sandy beach on a Great Lakes shoreline where people don't show up in the summer, there's really not that many nesting sites left for this species. There are two remaining in Wisconsin, the Apostle Islands in Lake Superior and Cat Island. Where's Cat Island, you ask? Oh. Right there. Been birding in Green Bay many times, but I haven't seen it because the road that goes out to Cat Island is closed, largely to protect the plovers. This is, of course, completely understandable, but it is a little annoying that a rare endangered bird that I've never seen before is so close. Around the time I first came to Valley New School, I noticed this passage about Cat Island on the Port of Green Bay website. Dang it. Scroll wheel. I'm not trying to hit it. Okay, this passage on the Port of Green Bay website. Due to public safety and ecological concerns, general or open public access to the Cat Island Restoration Project is prohibited at this time. However, in recognition of the educational opportunity provided by the project, supervised access opportunities are granted on a case-by-case basis under the decision-making authority of the Cat Island Advisory Committee, with direct consideration of upholding public safety and meeting project goals. Educational opportunity, I thought to myself. I am not going into a school where I can make whatever the heck I want. Educational opportunity. But that project never happened. I did some great projects, but so I never got around to doing the Cat Island project that I wanted to do. So then it came to my senior year, and I realized that if I wanted to do the project that would get me to Cat Island, it would have to be now. As for a wider subject, I obviously couldn't just make a project out of, I want to go see some piping plovers. So I decided to do a project on ecological restoration, since Cat Island is a somewhat important ecological restoration site, and it would be a project that could easily stretch to 300 hours and get something additional out of it, other than just seeing some birds. But I'll get back to my own experiences later. Ecological restoration is the process of restoring damaged land to a state where it can be used by wildlife. The damaged land can be any number of things, including a plowed field, a lawn, or a forest that's been too overtaken with invasive species. Basically, anything that isn't good wildlife habitat in the first place. Ecological restoration is an important process for conservation. It can take many forms, including taking land with nothing on it, such as an abandoned farm field, and turning the blank slate into a usable habitat for wildlife. It can also take the form of improving or protecting existing habitats. It's a very important process for wildlife conservation, but it is also important for several other reasons. Restored habitats restore carbon to better contribute to stopping climate change. Restored habitats also provide cleaner water, and a recent study found that farms with wildlife habitat around them have fewer pests and food safety risks than the farms without, even when the farms take additional measures to try to stop pests. And yet, stepping into philosophy for a brief moment, I don't think we should look at these things this way. The reasons go so beyond simply money and human health. The services of the ecosystem are what hold the biosphere together. Frankly, if the conditions of the planet's ecosystem continues to spiral downwards as it does now, humans will have trouble surviving. It would be an apocalypse like no other. People depend on the ecosystem all around us, even if it can be hard to tell sometimes. Saying that ecosystem services are valued at trillions of dollars makes it sound like we have a choice to restore these ecosystems. If we want to provide a future for our species and others, then we simply have to. The UN even agrees with me here and declared this the decade on ecological restoration. Our modern understanding of ecological restoration got its start from the same man who began the study of ecology, Aldo Leopold. Aldo Leopold was born in Burlington, Iowa in 1887. As a child, he fell in love with nature on his family's farm and eventually pursued a career in forestry. He He got a job at the U.S. Department of Forestry and began working on management at the Carson National Forest in New Mexico. There, one of the things Leopold did was eliminate the last pack of wolves in the Southwest, as was standard practice in forest management at the time. However, he noticed that after the wolves were eliminated, the forest changed. Thick brush of the forest floor was gone. The numbers of deer and other game animals increased, but the animals were much less healthy than they had previously been. Most non-game animals declined dramatically. Seeing this made Leopold realize how closely tied the ecosystem was. Eliminating wolves had ripple effects that cascaded throughout the ecosystem, having negative consequences on all things living there. Leopold would later say, a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. It is wrong when it tends otherwise. This is an extremely important quote that basically sums up all of ecology and also ecological restoration in one sentence. Practitioners of ecological restoration should take this quote to heart. Leopold would go on to found the study of ecology, a branch of biology focused on how different organisms interact in their environment. In 1924, he moved to Wisconsin to pursue these studies and eventually became the first ever professor of ecology at the University of Wisconsin-Madison. As part of his studies, he, as well as a couple of other biologists at Madison at the time, bought 1,300 acres of land just outside Madison in the 1930s. Most of this was abandoned farmland, pretty useless for wildlife, but there were some patches of remnant ecosystems among this land. Remnants are pieces of land that have never been altered by people. Leopold and his associates decided to try and restore this land to the original Wisconsin landscapes. This would become the UW-Madison Arboretum, the first ever attempt at modern ecological restoration. Throughout the property, a number of different ecosystem types were restored. Oak spans, prairies, marshes, and forests, and many other ecosystems from throughout the Midwest were replicated. The most famous site on the Arboretum is the 73-acre Curtis Prairie, which was the first restoration site on the property, and therefore the first ever. While Curtis Prairie was the first of many restored prairies, it is far from the best representation of the habitat. There are far too many trees to be a real prairie, and the invasive grasses were never eliminated in the first place, meaning Kentucky bluegrass has had a hold on the site since the beginning. However, many experiments have been conducted here that contributed to our understanding of prairie restoration. As with any first attempt, the UW-Madison Arboretum did make some mistakes that we now know better. Most notably, the planting of European alder on this site is what first introduced this invasive plant to the continent, which now invades swampy lands throughout the Midwest and the Northeast. However, despite a few errors, the Arboretum stands as an ecological jewel in the middle of Madison, providing habitat for many species of plants and animals. According to the Society of Ecological Restoration, there are 8 principles that all ecological restoration should follow. First, ecological restoration engages stakeholders. The local community should be involved, especially in large-scale restorations. This provides a great opportunity for education as well. Secondly, ecological restoration should draw on many types of knowledge. Local and traditional knowledge should be considered just as much as scientific knowledge, as well as the acquired knowledge of the practitioner. Thirdly, ecological restoration is informed by native reference ecosystems while considering environmental change. Remnants of native ecosystems should be studied, and the restoration of an ecosystem should largely be based on what can be found in those similar remnant ecosystems. Of course, be aware that these remnants may have changed over time through processes like succession. Fourth, ecological restoration supports the ecosystem recovery process. Practitioners should enhance natural recovery carried out by plants and animals. If native plants are recovering by themselves, the practitioner should focus on helping that along rather than putting in new plants. Fifth, ecological restoration is assessed against clear goals and objectives. It should be planned ahead. Sixth, ecological restoration seeks the highest form of recovery possible. Your goal shouldn't be to get rid of most of the invasive plants. It should be to get rid of all of the invasive plants, and then more after you're done with that. Seventh, ecological restoration gains cumulative value when applied on large scales. Small restoration projects are important and should be done, but the larger the project, the more impact it can have. And eighth, ecological restoration is part of a continuum of restorative activities. Ecological restoration is important, and many argue the most important step that people can take to help the environment. However, it's not the only one, and other things should be done on the side. To understand exactly what goes into ecological restoration, One must first understand ecology. Ecology is the study of how organisms interact with each other in the environment they inhabit. What insects pollinate what plants? What birds eat what insects? How do different plant species disperse their seeds? These are just a few questions asked by ecologists. Ecology has found that all organisms are closely tied to their environment. Every species on Earth has a specific set of conditions it can live in, and cannot live in an environment that does not fit its needs. Some of these conditions are very basic. Most species require oxygen. Some species die when exposed to cold temperatures, and others can survive only in cold temperatures. These are some of the more obvious ecological requirements, but then things get a bit more complicated. All species need food, and different animals eat different foods. Broadly, animals can be divided into two groups based on how many kinds of food they eat. Generalist eaters are animals that can eat a wide variety of food types: meat, fruit, leaves, insects, or a whole host of other foods, depending on the species. Generalists live and eat all of it. Generalists live in a wide variety of habitats because they rarely have trouble finding food. A great example of a generalist is a raccoon. Where raccoons live, raccoons are found in all environments because they're able to find food everywhere. Forest, wetland, prairie, middle of the city, they don't care. Specialist eaters are animals that require one very specific type of food. They may only eat the leaves of one plant species or the meat of one bird species. In any environment, the prevalence of any given specialist eating species is dependent on its food supply. For example, giant pandas are specialist eaters, as they only eat bamboo, and their abundance in any given Chinese forest is completely dependent on the abundance of bamboo. If there isn't enough bamboo to sustain a panda population, there cannot be pandas. Not all specialists are specialists throughout their entire lives either. For example, monarch butterflies feed only on milkweed leaves as caterpillars. However, adult monarchs are generalist pollinators that can feed on the nectar of almost any plant, as well as even a few other food sources, such as fruit, animal scat, and carrion. Yeah, most people don't know what butterflies like carrion. However, since they are milkweed specialists for part of their lives, the local abundance is still entirely dependent on local milkweed populations. Like the panda, if their special food item isn't available, they cannot live in that area, even though they are generalists for most of their lives. Not all specialists are specialist eaters as well. For example, Kirtland's warblers are generalist eaters that feed on a wide variety of insects. However, they are specialists as they require a very specific environment for nesting, called the jackpine barren. These environments are open grassy fields with an abundance of young jackpine trees, which are taller than 5 feet, but no taller than 15 feet. In any other environment, Kirtland's warblers are unable to nest. Although there hasn't been any study that has attempted a good calculation for how many species are generalists or specialists, it is likely that over 90% of animal species are specialists in some way. Given that only generalist species are likely to adapt to human-modified landscapes, it's no wonder that so many species are endangered today. When restoring an ecosystem, it is important to make sure that many different types of foods and environments are available, so as many animal species as possible can utilize the space. Another important ecology concept to consider here is invasive species. Invasive species are species that are introduced by humans to a new area where they did not previously occur. Then, thanks to the lack of predators or other limiting factors in this novel environment, they are able to take over and drive out native species. Invasive species can be animals, plants, or fungi. Invasive species are a huge issue around the world, including here in Wisconsin. The Wisconsin Department of Natural Resources lists 238 species as invasive in the state. The number is actually probably higher. As a great example, one of the worst invasive species in Wisconsin is this plant, the common buckthorn. Common buckthorn is a plant native to Europe that grows as a bush or sometimes a small tree. Common buckthorn spreads quickly and can grow in full sun or full shade. After just a few years of being detected in the forest, it can completely take over the understory, choking out any other plant species, whether they be bushes or understory forests. After just, it can form a dense monoculture and become the only species in a forest, other than the tallest trees, that it can't choke out. This is an issue because nothing eats buckthorn. Before it invaded a forest, that forest likely had hundreds of species of native plants growing in that understory, each of which probably had at least several specialist animals feeding on it. Now that the buckthorn has taken over the forest, all those animals are gone. It's not suitable habitat for anything anymore. Control and or eradication of invasive species is one of the most important steps in ecological restoration. Another ecology concept that is important to understand for ecological restoration is fragmentation. At one time, all of Earth was simply a vast wilderness, but as humans have come to dominate the Earth, about 70% of Earth's land surface is now dominated by humans in some way. Now, nature is no longer continuous, but divided into smaller pieces. That's fragmentation. Fragmentation has huge consequences for all the plants and animals that live there. First of all, an ecosystem being fragmented fundamentally changes the landscape, even the individual fragments. On paper, the kind of fragment of a forest would seem to operate the same way as that forest once did as a whole, but that's never the case in practice. Many forest species thrive in low light levels that the forest canopy creates. Once the surrounding forest is cut down, more light is let into the forest, which can make it difficult for those species to survive. This isn't just a problem on the immediate edges of the forest. These problems can affect species living up to 100 feet into the forest fragment. Another effect of fragmentation is the loss of species when the forest becomes fragmented. An ecosystem can never operate properly without all of its species present, but some species are more important than others. Those most important species are called keystone species. If keystone species are lost from an ecosystem, the effects can be drastic. As an example, let's take a look at this theoretical forest fragment. It once looked something like this, a vast forest. But nowadays, the forest only exists as tiny fragments separated by suburbs and agriculture. One of the first, most obvious effects is that any species that cannot handle these conditions goes, and quickly. This includes hundreds of species of animals, mostly insects and birds. Many of these animals disappeared because they required large, uninterrupted territories. One such species is the gray wolf, a keystone species. Before our forest became fragmented, there were many wolves and an abundance of deer for them to feed on. After the wolves leave, something interesting happens. As deer are extremely adaptable generalists, they are able to handle these new fragmented conditions. And without wolves to keep their numbers in check, their population explodes. Within the remaining forest fragments, deer eat away at the forest's understory. Species that were previously able to handle the forest fragmented state are no longer able to handle that lack of a forest understory. This includes many more species, especially birds, and unfortunately, pollinators, which of course are some of the most important animals in any ecosystem. Thanks to the lack of wolves and important keystone species, most of the species that could live in these forest fragments no longer do. Species don't even necessarily have to have large territories to initially disappear from a fragmented landscape either. Fox turtles, as well as most other reptiles and amphibians, have a hard time living in heavily fragmented habitats, simply because they usually get trampled by humans and their vehicles. Many insect species run into similar problems. Fragmented ecosystems are also more easily invaded by invasive species than non-fragmented ecosystems are. So, how would one go about restoring this theoretical fragmented forest? One of the most important steps would be to establish wildlife corridors. When an ecosystem becomes fragmented, populations of animals and plants that inhabit the different individual fragments interact less than they previously did and become vulnerable to inbreeding. If we connected the individual fragments with corridors of suitable habitat, then the animals would be able to use these corridors to go between the fragments. Invasive species would have to be eradicated and heavily controlled in all the area and the fragments. For plants like buckthorn, this would involve manually pulling every plant out of the ground, or possibly using chemical control if that seems impossible or impractical. Finally, something would need to be done about all those overpopulated deer, as they are harming the other species in the ecosystem. As Aldo Leopold said, a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. It is wrong when it tends otherwise. In this situation, although the deer are a native species, they are no longer contributing to the integrity, stability, or beauty of this community, and therefore have to be dealt with. There are few options on how to deal with them. Fences could be erected over large areas to keep them out. This is by far the simplest option, but it really only does anything within the fence areas and is really more of a workaround than an actual solution. The second is to cull deer. This is simple in theory, but it's usually difficult to get approved, as hunters and animal rights activists tend to fight against those kinds of proposals. However, when it does go through, it is very simple and extremely effective. Thirdly, predators could be reintroduced to the system. This, of course, requires there to be suitable habitat for predators in the first place, and that those predators would not come in conflict with humans that live there. That's not possible in this situation. Some other ecology concepts that are important to understand for ecological restoration are disturbance and succession. Disturbance is a change in environmental conditions that disrupts the functioning of an ecosystem. Disturbances can be natural or human caused. Some examples of natural disturbances could be a flood or a lightning spark wildfire. Some examples of human-caused disturbance could be clear cutting of forests or wildfire lit by a person. Disturbances all have various effects on an ecosystem, some positive and some negative. Succession is the process by which an ecosystem changes over time. Ecosystems are not static. They always change slowly. For example, a field may succeed into a forest as nearby trees sow seed into the field. Successions are often tied to disturbance. A forest can change into a grassland pretty quickly if it burns down. Some ecosystems require continued disturbance to be maintained, otherwise they succeed into a different environment. For example, if prairies do not experience a fire every few years or so, they will succeed into a forest. Ecological restoration often involves initializing or limiting disturbance or succession, depending on the particular situation or ecosystem that is being restored. The process of ecological restoration begins by having a planetary site. What type of ecosystem should it become? The restoration practitioner should know what a pristine version of local environments looks like. Wisconsin has a lot of different types of ecosystems, including 11 types of forests, 8 types of grasslands, 6 types of savannas, and 5 types of wetlands. The restorer should be familiar with each of these and evaluate which ecosystem type would be the best for the site in question. In most cases, this should be fairly obvious. Unless you are dealing with a completely blank slate, such as a farm field, your site probably already represents one of these habitats, although it is likely heavily damaged or overtaken by invasive plants or even animals in some cases. In most cases, you should simply restore your site to a healthier version of the ecosystem it already represents. But in some cases, you may want to change the site more drastically for some reason, or transition it to a whole new ecosystem. The most common reason to do this would be to change a common ecosystem into a rare one. There are lots of forests around, but there aren't many prairies around, so perhaps transitioning your site to a prairie would be more valuable. Of course, not every site can become any ecosystem. All ecosystems have certain requirements, such as humidity, temperature, water levels, or soil pH. After determining what type of site you want, you need to prepare your site for restoration. Most of the time, you probably aren't changing your site too much, so this usually involves removing invasive plant species and planting native ones in their place. However, for more drastic changes, you may have to take more drastic steps. Turning a forest into a prairie, you'll have to remove all the trees first. Making a wetland, you'll need somewhere to put all the water. Regardless of what you're doing, you will be causing disturbance, and we'll need to make sure all of the plants you put in are native. Invasive plant removal will be involved. From there, the process will be different depending on what you're doing. Need a prairie seed mix? Does your site need controlled burns? Speaking of that, one interesting tool used in some ecological restoration methods is fire. Some habitat types, such as prairies and savannas, require fire to be maintained. Historically, this was done mainly through lightning spark wildfires, but after centuries of fire suppression, this no longer happens, at least not in the Midwest. The plant species that are found in these ecosystems are well adapted to fire and actually grow better this way. For example, jack pine trees will only release seeds if their cones are on fire. Another reason fire is used in ecological restoration is to prepare for an uncontrolled wildfire. The recent wildfires in the western mountains have been bad, largely because of all the dry brush and grasses gathered on the forest floor. Historically, these ecosystems went ablaze occasionally without much issue. Ponderosa pine, the dominant tree in most western mountain ranges, is actually fire dependent, just like our native jack pine. However, because most of these mountains have not burned in centuries, when fires spark, they spark more intense than they did historically, largely thanks to all that dry brush and grass that has never been burned. And this can really ruin a forest. However, if the brush is cleared away first in a smaller control burn, a coming wildfire can instead benefit the local ecosystem. Take a look at this aerial photo of Sycan Marsh in Oregon after the bootleg fire raged through in the summer of 2021. The area that had a controlled burn remained as the last bit of green forest for many miles in any direction. One of the first things I did for this project was actually get out to Cat Eye. I was able to go out there with DNR ecologist Joshua Martinez. We went in the middle of winter, so unfortunately all the pipe and photos were actually in the winter range in the Bahamas. But I did get to see the property and some of the things they do out there. I also got to see some nice birds there regardless, including snowy owls. One day, while going through the Valley School Library, I found this book, The Vegetation of Wisconsin by John Curtis. This book, from 1959, is a somewhat rare book on the ecology of Wisconsin's flora, and I would love to know how it ended up in the VNS library. This book is not about restoration, but it does contain one of the most rigorous studies on the ecology of plants ever, and was written with the restoration practitioner in mind. I read this book several times over the course of the project and wrote thousands of notes on all the glorious information in it. If I had the time, I could write a few thousand more notes. But the most important thing I did for this project was my own restoration site, right here at Heckrock. Heckrock contains a few different habitat types, but most of the property is covered in a community called Southern Hardwood Swamp. Some areas within Heckrock are higher up and do not flood as much during the year as the Southern Hardwood Swamp normally does. These sites, these sites are this way because the soil was filled using filler from paper mills in the 19th and early 20th century. Swamps aren't exactly the most well-liked of natural communities. This has permanently altered the soil chemistry in ways no one entirely understands. Certain plant species seem to thrive in these anthropogenic conditions, and other plants die very quickly. Regardless, these areas are too dry for most of the water-loving plants that naturally grow in southern hardwood swamps. That's the filled areas. The dominant tree species here at Heckrock are silver maple and green ash, both native deciduous trees that thrive in wet conditions. Historically, American elm would have been a dominant tree as well. Unfortunately, trees that grow in all southern hardwood swamps, including Heckrock, are under threat. The aforementioned American elm is a great example. The American elm was once called the Great American Tree and the champion of the floodplain, dominating swampy wetlands throughout the eastern United States. These impressive trees commonly grew more than 80 feet tall and 60 feet wide. These trees were vitally important both ecologically and economically, providing habitat for hundreds of animal species, and their fast-growing nature made them excellent street trees and lumber providers. Then, everything changed when the Dutch elm disease attacked. This fungal disease is native to Asia. The native Asian elm species are resistant to this disease and usually survive its attacks, but the native North American elm species have no such ability. When the disease arrived in the late 1920s, elm trees began dying all across the continent, with the last of the giant elms dying by the early 1970s. The elm tree is still around. The tree is no longer able to soar to great canopy heights, but it is common as an understory tree in most areas, since the disease kills trees after they reach maturity. This is a huge loss for once elm-dominated forests, however. And the green ash, one of the tree species currently dominant at Heckrock, is facing similar trouble. A species of Asian beetle called the emerald ash borer was first discovered in Michigan in 2002. The larvae of this beetle feed on the wood of ash trees. The native Asian ash species are able to survive this thanks to a chemical they produce that deters the larvae and most of the trees very sick. But North American ash species do not produce this chemical, so they die after the beetle feeds them. Currently, the emerald ash borer is spreading across the continent as we speak. Currently, ash trees are some of the most common and important trees in Wisconsin and pretty much every other state and province in North America. But it seems likely that within half a decade, all these trees will be dead thanks to this beetle species. The situation in many other states and provinces is just as bleak. Unlike Dutch elm disease, emerald ash borers are able to kill their host before they reach maturity, meaning that the several North American ash species, including green ash, will all likely go away in the pasture region over the next couple of decades, once extremely abundant but now completely extinct. This will leave silver maple as the single dominant tree species at Heckrock. By the way, I also have a specimen of an emerald ash borer here, which I will pass around. It's amazing that these tiny little things cause so much destruction. My restoration site at Heckrock is on the northwest part of the property and is roughly 900 square feet in size. It's located on one of the field sites, so it therefore doesn't usually flood. The trees are mostly planted conifers, making the site floristically unique within the property. The notable tree species on the site are the native white and red pines, as well as the non-native Norway spruce and Scotch pine. The brown layer of the site was dominated by thick stands of highly invasive common and glossy buckthorn, as well as hundreds of green ash seedlings. The first obvious step was to get rid of the buckthorn. Both of the buckthorn species present there currently are highly invasive. Through removing the invasive plants, they need to be replaced by native plants. In some cases, the native plants already on the site are able to replace the invasive species by themselves, but unfortunately, the green ash seedlings on the site aren't doing that. This means I had to buy native plants and plant them manually, which is quite expensive. To do this, I applied for a grant from Wild Ones, a local native plant society in Fox Crossing. I received a $500 grant from them, and along with other donations I received, I was able to purchase $1,000 of plants to add to the site. I picked some intentionally aggressive plants in hopes they would compete with the native buckthorn, including somewhat ironically, the native species of buckthorn, the elderly buckthorn. We also added a fence around some of the sites to reduce deer grading, as they would almost certainly destroy the plants we get. Peckrod suffers from many of the same issues as our fragmented forest order. Some volunteers already planted tree species out there, and the other plants are coming later this month. I'll probably plant some of them. After this presentation is over, we're going to go over there, and everyone is going to pull invasive plants because there's still a bunch out there, and we need to get rid of them. You all get to experience ecological restoration firsthand, whether you like it or not. In the fall, so I'll be attending UW-Stevens Point for plan to study wildlife ecology and management. I will now accept questions.
What is some advice that you would give to future seniors?
Do something you want to do. You could tell I was passionate about this project. If I had picked pretty much anything else, it would have been pretty boring. But I was out here. This really gave me an excuse to get out into the woods instead of go out to school. I was much rather than going to a farm than sitting at my desk, rearranging all my animals. Crazy.
Please tell everyone the story about the CD you found of I Put a Spell on You while you're doing some work out here.
That is completely irrelevant to this project. I'm not telling you.
Are there ways that people can do some ecological restoration at home, like some plant species we can put in our backyards for people who don't like the 18th century French grass?
Thank you. I was really hoping I would get this question. Ecological restoration can be done at home. You're not going to be doing a big scale project, but there's some very simple things you can do at home. First of all, you want native plants. You can go to things like the website Prairie Nursery or a few others. There's a place called Stone Silo Prairie Gardens in Depew where you can pick up some native plants. Any native plant is better than any non-native plant, so you should really have your gardens containing native plant species. It's also, you want to eliminate a lawn as much as possible. Lawns are completely worthless to wildlife. Anything else is better. So try to eliminate lawns. Most moth species, and moths are some of the most important insects you can have in a home ecosystem because you're not going to get many reptiles or mammals in a suburb, but you will get birds. And birds, most songbirds are specialists on moth caterpillars. So you get a big tree, especially like an oak or a maple, something like that. You plant it. That's a great source of food for moth caterpillars. You get hundreds of species of moths, and then you plant native wildflowers under that. That's like the best habitat you could possibly have. I don't know your answer.
Okay. So I'm just wondering. So do a lot of birds eat stink bugs? I'm just curious.
Not many birds will because the stench usually repels them. Some bird species don't have a sense of smell, so those ones don't care. But yeah, some birds will, some birds won't.
Are there large-scale ecological restoration opportunities for volunteer opportunities?
It's hard to find opportunities among the largest scale projects. Usually they like to keep those closed. You can find tons of opportunities. If you volunteered in here, you could get a lot of that. Yup, Andrea wants to volunteer.
Volunteer coordinator, please volunteer. Okay, so what would be like your favorite or most interesting bird you've seen at
Or I've seen that's a long list. I heard a Connecticut warbler once, couldn't see it. Oh yes, there were gray horned owls that nested there for a couple years. There's a barred owl nesting somewhere in the wetland out there. Probably gray horns too. Yeah, I wasn't prepared for that question. If I was, I'd have a more interesting answer. Caitlin?
Are there any popular animal species that you don't like personally?
I mean, I don't really like anything that's invasive. I can't. Most notably feral cats. You knew I was going to answer with that.
Yeah.
Feral cats are probably the most invasive animal we have in Wisconsin, other than those ash borers. They have no predators. There's tons of them around. People think, oh, you don't like house cats? No, no. Feral cats are everywhere. They just never show themselves. They eat all the birds. It is terrible.
Absolute worst invasive species is the United States.
United States, at the moment, it's probably the ash borer. There's a lot of other great contenders to that. Red reported fire ants are terrible. Feral cats are terrible. What's that? Wheat canary grass. There's so many bad things.
Is there still hope for ash trees, or is it like too far gone?
It's difficult to tell at this point. I would hold your breath. They've been able to develop recently strains of elm that are resistant to Dutch elm disease. That's still a work in progress. They don't grow very well, but that's theoretically possible because it's a disease. Emerald ash borers directly hit the wood, so it doesn't seem likely that there's any way to disturb it. Recently, it was found that the blue ash, which is a species of ash that grows in the Appalachians, actually produces a chemical similar to the Asian ash species. And they've also found that through ash borer infested areas, about 1 in every, 6 million ash trees just survives for some reason. So it's possible they might be able to find something with those trees. But honestly, if you have any ash seedlings, get them inside and do an seeding project. Good?
What's your favorite native edible plant?
Edible plant? I don't really try most edible plants because I'm more focused on getting them into the ground. Strawberries are pretty good.
What is a not native bird you want to see?
What?
What is a not native bird through Wisconsin that you want to see?
That I want to see?
Yeah.
I have seen all the non-native ones in Wisconsin, I think. European goldfinch I only have a tiny great view of, so I guess that counts. Very true that there's a population here, but it doesn't seem Louis and they fly over here sometimes. There's just one in Merrimack that I couldn't go chase because I was too busy working on this presentation. I would much rather have been in Merrimack looking for that bird.
Do you know anything about like the disciplines Canada days in northern Wisconsin?
First of all, I don't think it was great, Jay.
I thought they changed the name.
They did change the name, I don't care. It's likely, it's probably related to a few different things. Part of it is probably climate change. Part of it is probably that a lot of border forests there's less around. I'm guessing that part of it is just that they're viewed less often. They're just retreating into more less explored areas, but it's hard to say.
What would you say is the best place to go view wildlife?
Wisconsin, Oregon Marsh. There are lots of great sites around the site, but Oregon Marsh kind of blows me.
Where do you see yourself?
I have no idea. I'd like to think into the future, so. Okay.
We spoke to things we can do to reverse problems now. Are there things that we should be doing to prevent? Like things we could do to prevent more invasion from other species that don't belong here? Or
That's hard to say on the individual level. A lot of that is really, I guess, problems for, I don't know, but like, you know what I mean. I guess the best advice I can give you as far as stopping like invasions would be to plant native plants and like don't release pets. But So, I mean, I kind of started with Cat Island, so I researched that, and then contacted a couple people relating to that, and it was actually pretty easy to get out there. As far as research on the topic, I mean, I took so many notes on that vegetation in Wisconsin. I didn't even get halfway through it with my notes. I have thousands, I was not exaggerating. But I also, I mean, I kind of just Googled particular ones I was interested in. I didn't get to talk about Raymie wildland in this presentation, but I looked into that a lot, looked into restoration of fire. I had wanted to help with a prairie burn somewhere because I thought that was interesting, but that the one I had set up fell through. Yeah.
What was the process that you utilized to connect with TechRock for this project?
I know them already. I have been coming here since a little kid. I already know all the staff here from a lot of things. I volunteered here. I've just been here so many times that there wasn't a process in me starting that because I basically just went over here one day and said, hey, and that's it's fun.
Two questions. First of all, in regards to Hazel's, what was your note-taking system?
I just put things into Google Docs and then kind of organized them.
Okay. And secondly, you went to Cat Island during a time when the bird you wanted to see
Yes.
wasn't there. Do you envision yourself going back?
I don't
see
think
this?
it's likely I'll get a valid excuse to get back. Plan B, I guess, is to get out on a boat in the bay and try to see if I can see it from that. I don't know. Peter?
In the future, do you see yourself working with like larger scale ecological restoration or no?
I don't know. Like I said, I don't think about my future much. I guess vaguely, that's what I imagine. I don't know.
What was your overall base to conquer through this project, or like your proudest moment through this project?
The beast to conquer that I put at the beginning was logging because I'm terrible at it, and to be honest, that didn't really use that much. My proudest moment of this project is definitely working out there. It's nice to see the piles of basically about 4.5 feet bigger, to the point where, I mean, they've been moved, so I don't know if it's still at this point, but I had several piles that were taller than me at one point.
How did you like obtain that spot?
I just asked, hey, I need a restoration spot, and
It's true.
What was some of the best advice that you received throughout the project?
I'm not sure.
Did anything stick out to you?
Not really.
I have two questions. I know you said you don't like thinking about your future, but is there so two questions. Is there an area that you want to visit to help restore the environment? And do you think you'll come back to Heckrod and still volunteer or work here?
As far as the Heckrod thing, exactly what my summer's gonna be like is up in the air, but it is very likely that I will get back here over the summer and do some stuff. I'll definitely be walking here because I always have. As far as the place I wanna get to, I don't know, I mean, I'd love to work with restoration projects around the state, that would be super interesting. I don't know if there's any particular area that sticks out to me.
Do you want to stay in the Midwest with your restoration, or are you looking to branch out to other areas of the
I'm not
Midwest?
interested at this time in going far.
Do you think that there's a specific part of the world